Chapter 17 introduces some data sets that are built into R. First command here is going to be the library command, and I'm going to say help is equal to data sets in double quotes. And when I hit that command, it is going to produce some information on the package called data sets. And these will be some of the data sets that are built into R. And you can see up at the top here, they are put in alphabetical order. This is the name of the data set. For example, air passengers is the monthly airline passenger numbers from 1949 to 1960. And keep in mind that the case is important here. It's case sensitive just like everything else in R, so you have to have a capital A and a capital P. And you can see there's everything from weights on chicks here to daily closing prices of major European stock indices, formaldehyde, etc. We will be looking at some of these data sets in the session here on Chapter 17. Let's start out with one of the built-in data sets, and the name of it is state.x77. I'll go ahead and type it, and I'm going to have to scroll back up so you can see what we have going on here. Is we have in alphabetical order, the row names here are the 50 states, and then the column names are the population. And by the way, this is the population in hundreds of thousands back in 1977. Here is the income, again back in 77. Here's the illiteracy rate as a percentage. Here is the life expectancy in years. Here is the murder rate. Here is the high school graduation rate. Here is the average number of days of frost. And here is the area in square miles. Now, if you want to learn more about these various columns, you could type in state or help state.x77, and it will tell you over here in this window, in the bottom right window, it'll tell you a little more about the state.x77 data set. Notice that this is a matrix. That's its data structure. It has 50 rows for each of the states, 8 columns, giving the following bit of information. So you can see here are the details and the sources for these types of things. Let's work with this data set a little bit. State.x77, you can use a subscript here in the usual fashion. So for example, if I say state.x77 8, comma, that's going to give me the 8th row of this matrix. That row happens to be Delaware, and so here is Delaware's population, income, illiteracy, life expectancy, etc. I could go in the other direction, and I could also say state.x77, except this time I'm going to go and look at the 8th column. Now in this case, the 8th column includes all of the 50 states, and if you look over here at what that 8th column is, that turns out to be the land area in square miles. Now keep in mind that this is actually a vector now. These elements here are vectors. Alabama at 50,708 square miles, Alaska at 566,432 square miles. And we can use the sort function, for example, to sort these values by the size of the states. The state names here are metadata. They are not part of the vector, but they are metadata. So I could take that previous command here, put a sort in front of it, and I will get the states sorted by size. And you can see the first of those is Rhode Island, followed by Delaware, and the largest state is Alaska. And there they are sorted. You take two vectors and create them. First vector is going to be the illiteracy vector. And the way I'm going to get that is I'm going to say state.x77, and I am going to extract the third column, and that will give me illiteracy. Now I don't want to fill up the screen too big, so I can use the head function here and just look at the first 5 or 6 of them. And so there's the top of that group. And then I'm going to make another one called frost. This will be a vector, and I will go state.x77, comma 7. And if I do the same thing here and say head frost, this will give me the first 6 of the states in terms of average number of days of frost. Now at this point, I can write a function, something that we hit in an earlier chapter, and I can say is.max. I'm going to write my own function called is.max, and it will look like this. Is.max is a function, and it takes on a vector x. What I'm going to do here is let it pick off the largest. So it'll take a vector and determine which elements of that vector correspond to the maximum. Might be just one, or it might be quite a few. So I can now say I want the state names. So there is a state.name built-in data set, and I can ask this question. I can say is.max of the illiteracy vector. And what I get is I get the state with the highest illiteracy rate, and in this case that is Louisiana. Then I can do another one. I can say I'm looking for the state.abbreviation, and in this case I want the state.abbreviation is.max of frost. What has the most frost? And surprisingly, that's Nevada. You would assume that that would be Alaska, but it doesn't turn out to be the case. Here's another one. I can say, show me all of the illiteracies of the states that are less than 1. When do we have less than 1% illiteracy? And you can see there are the states that have the lowest illiteracy rates. If you want to say how many of those states are less than 1% illiteracy, you could just do a count of them with the length function. And now we know 25 of the 50 states have an illiteracy that is less than 1. Here's another one. We could say sort of frost. This will sort the frost vector. And let's say we want to get states 41 through 50. This will give us the 10 coldest states in the United States. And you can see most of them are located along the north there, and those are the ones with the greatest number of days of frost. So that's a little bit of manipulation of the state.x77 data set. I'm going to introduce a few more data sets that are out there. The first ones I will call univariate data sets. And I won't do all of them, but I'll do a few of them. Here's one called islands. And what islands gives you is the areas of the 48 land masses that exceed 10,000 square miles. So you can see some of them are huge, like Africa, for example, or even bigger would be Asia. Australia is big. And you can see some of them, once you come down, are going to be a little bit smaller. But these are the 48 largest land masses in the world. Here's another one. It's called Precip. And again, I've got to scroll up a little bit. But what Precip gives you is it gives you the average annual precipitation in inches for 70 United States cities. So again, once you have that, you can say, where was there the most rain? 67 inches. Where was the least amount of rain? Oops, I got to go to min. And the minimum is 7. So you can work with those functions on univariate data sets. One more is rivers. And what rivers gives you is the average length in miles of 141 rivers in North America. So there they are as a vector, and there's 141 of them. Some of the data sets are not univariate data sets, but rather they are paired data sets. And here are a couple of them. First one is called cars. And in the cars data set, you can see there's 50 observations, and there are 2 different columns here. The first column is labeled speed, and this is the speed in miles per hour, and the second column is the stopping distance. Now you might wonder why people care about a car that is only going 4 miles per hour, and if you want to find out a little bit about the cars data set, all you have to do is say help cars, or you can just say question mark cars, and you'll see why they were moving so slow. These data were recorded way back in the 1920s. So that's why the top speed you can see here at the very bottom is 25 miles per hour. Here is another paired data set. It is women. And in this case, you have the average heights and the average weights for 15 women who are in their 30s. Here's another data set. It's formaldehyde. By the way, when I get to this point and I've typed in form, it'll know that it is formaldehyde. So if I hit the tab character, it'll complete the rest of the name of the data set. But formaldehyde is a small data set, and it is carbohydrate, which is that first column, versus the optical density. And so that's a nice data set that can be used for regression or some other purposes, which we'll see a little bit later. The next type of data set that I'm going to look at, and again, more are considered in the book, is a time series. And here are a couple examples of time series. The first one is going to be US POP. Every 10 years there is a census, a decennial census, and this is the censuses that were taken from 1790 to 1970 in the United States. Again, a time series, you can see this is, got the name of a time series, starts in 1790, ends in 1970. So if I were to do a structure here and put in US POP, it will tell you that it is, in fact, a time series. There are 19 elements. It starts from 1790, goes to 1970, and here are the first few of the values in that time series. Here is another time series. It is called Air Passengers. And what this is the air passenger data starting from 1949 and running through 1960. And you can see across the top here are the various months. So you could come down here and ask a little about air passengers, and you would get some information off to the right. If you want to know what kind of data structure this is, you would find that it is also a time series. Finally, a third example of time series is the data set presidents. Here you can see these are quarterly approval ratings from 1945. That would probably be Harry Truman through the Eisenhower years and all the way up to the 70s where you had Nixon in office. The next type of data set, incidentally, I'll throw in this just before I get to the next one. Sometimes you have missing data in some of these built-in data sets, and they didn't get quarterly presidential approval ratings in 1972 here. So that's why you see the NAs. Another type of data set is called count data. And one of the famous data sets that is out there is the Titanic data set. So if you type Titanic with a capital T, what you'll see is you'll see the data values. I'll scroll up. And this particular type of data is got what's known as a binary response, whether the individuals survived or did not survive the sinking of the Titanic. And in this case, the group did not survive, and these were children, and it shows you which class they were in, first, second, or third class, whether or not they were a crew member. And this next group right here are adults. These adults did not survive, and you can see here they are by their gender, male and female, and which class they are in. And so this is an example of a binary response, because the response is either yes or no on surviving. And it's helpful to see the differences between the genders. And here, for example, are some that survived, and you can see here is male versus female. And based on the various classes, first class, second class, third class, there's quite a discrepancy here between male and female. And finally, the last type of data set I'm going to call a multidimensional data set. And I'll just do one example of this. And this is the data set that's known as quakes. So not univariate, which is one variable, not paired, which is two variables. Here we have several variables that are being included. And it turns out they omitted 800 rows. So this is clearly a very big data set. So let's try a head function on this. And I'll follow that up with a tail. So we get the first 6 and we get the last 6. So what's going on here is you have 5 variables that are collected on 1,000 earthquakes near Fiji. And what is collected on them is, first of all, the latitude and the longitude of where the earthquake occurred, then the depth of the epicenter, then the magnitude measured on the Richter scale, and then the last variable there is the number of stations that picked up the earthquake. So this is just a sampling of some of the data sets that are built into R. I would encourage you to take some time and look into these data sets and try to practice extracting things that you might be interested in. And the next topic will be input and output.